Hello, welcome to Pragim Technologies. I am Venkat. This is part 58 of SQL Server. In this session, we'll learn about transaction acid test. Before continuing with the session, I strongly recommend to watch part 57 of this video series. We know that a transaction is a group of database commands that are treated as a single unit. A successful transaction must pass the acid test. That is, a transaction must be atomic, consistent, isolated, and durable. Let's see what we mean by each one of these. A transaction must be atomic, meaning all statements in the transaction either completed successfully or they were all rolled back. The task that the set of operation represents is either accomplished or not, but in any case not left half done. Let's see what we mean by this with an example. I have two tables here, TBL product and TBL product sales. TBL product is like an inventory table which contains the information about the products and the quantity available. Now whenever we sell a product, an entry should also be made into TBL product sales table. So when we sell a product, two things should happen. First, we should check the quantity available. Let's say, for example, I'm selling 10 laptops. The first thing that I have to do here is to check, okay, what's the quantity available for laptops? 90. And then from that quantity available, I will have to deduct the 10 laptops that I'm selling. So we have to update this quantity available to 90 minus 10, 80. And then we also have to make an entry into this TBL product sales table. Product ID is 1 and the quantity I am selling is 10. Okay, so basically when we sell a product, two things happening: update TBL product table, insert a row into TBL product sales table. So that's what this transaction is doing here. The first statement updates TBL product table, and the next statement inserts a row into TBL product sales table. And these two statements are wrapped inside a transaction. So the atomicity of a transaction states that both of these statements should be treated as one unit. Either both of them succeed. If one of them fails, the data that's modified by the other statement should be undone and rolled back, so that the database is in a state that is similar to before we have begun the transaction. So either both of them should succeed or none of them. Okay, that's what is the atomicity of a transaction. The transaction should also be consistent, which means all data touched by the transaction is left in a logically consistent state. For example, if stock available numbers are decremented from TBL product table, then there has to be an associated entry in TBL product sales table. The inventory can't just disappear. So for example, if I'm selling 10 laptops, the first update statement reduces that quantity from laptops quantity available here. And then let's say when we are about to execute the insert statement into TBL product sales table, the power has gone or something has happened. In that circumstances, a transaction should undo the first statement and put it back to 90. Otherwise, we cannot account for those 10 laptops. So that's what consistency says. All data touched with a transaction is left in a logically consistent state. The transaction should also be isolated. What we mean by this, the transaction must affect data without interfering with other concurrent transactions or being interfered with by them. Okay, so if there are two transactions, transaction A and transaction B, transaction A shouldn't interfere with transaction B, and similarly transaction B shouldn't interfere with transaction A. Both of them, should work as a single unit of work, and they shouldn't interfere with each other. Okay, let's see how transaction achieves isolation. I have this table here, TBL product. Now let's say this is one of the transactions where I am updating this table, TBL product set, let's say quantity available is equal to 350, where product ID is equal to 1. And now let's make this update statement part of the transaction. So begin transaction. So now when I execute this, look at this. a transaction is now being processed on TBL product table. We haven't committed this transaction or rolled it back, so this transaction is still being processed. Now let's say there is another person who connected to the SQL server, and he is also trying to update the same table. So update TBL. So he issued, let's say, another transaction, or let's just say he's trying to update the quantity. Now before updating, he wants to select the data and see, so he is issuing a select statement. So now when I say select star from TBL product, when I execute this, look at this, it says executing query, but it will never get access to that table. Why? Because there is a transaction that is still being processed. It's not completed yet. That's why other users by default will not be able to see the data that is being touched by the other transactions. So here there is one transaction which is processing a record from this table. If you look at this, there are two records in this table. Currently we are updating the first record, which means this transaction is still being processed. We haven't committed or rolled that back. So now when I say select star from TBL product, it says query, executing query, but it's not showing, it's just waiting for the transaction to complete. On the other hand, let's cancel that, and when I say select star from TBL product where product ID is equal to 2, I'm selecting a row where the product ID is equal to 2. Look at this, the moment I execute that, I immediately get that row. But then when I try to get the row with ID is equal to 1, that is being updated by the other transaction in the other connection window. Look at this, it says executing query. So why am I not able to see that? Because that row is being locked by the database, because another transaction is currently being processed. So this transaction is not interfering with this transaction here. So the transactions must be isolated. So how does the transactions achieve this isolation? Basically using locking mechanism. We will talk about transaction isolation levels in the next session. Okay, so this isolation, this actually prevents transactions from making changes to data based on uncommitted information. For example, changes to a record that are subsequently rolled back. Most databases use locking to maintain transaction isolation. Okay, so here I haven't committed any data yet. This transaction is still being processed. I haven't committed any data yet. That's why this user is not able to access that record. Now if this user were able to access that record with product ID is equal to 1, then he might see uncommitted data, because this transaction is still being processed. I didn't commit the data, I didn't make the changes permanent to the database. So this user might see uncommitted data, and he might make his decisions based on that uncommitted data, which I may later roll back. So in which case his decision might be wrong. So when I roll back that, he might see only the rolled back data. That's why by default, if a transaction has locked a row, other users will not be able to see that. So a transaction should also be isolated. And a transaction should be durable. And this is pretty simple to understand. Once a change is made to a database, it's permanent. If a system error or power failure occurs before a set of commands is complete, those commands are undone and the data is restored to its original state once the system begins running again. So let's say, for example, we are executing a long running transaction, and let's say half of the data is modified, and then all of a sudden there is a power failure. So when that happens, when the power comes back, the database should be in such a position it has to roll back and undo the changes that it has already done and leave the database in a consistent and durable state. That's what durable means. Alright, if you want to receive email alerts when new videos are uploaded, please subscribe to my YouTube channel at youtube.com/KUDVENKAT. On this slide, you can find resources for ASP.NET C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.